Imagine a future where reaching space doesn't involve a violent rocket launch but a smooth, quiet elevator ride. This isn't just science fiction anymore. Today we'll dive into the fascinating concept of the space elevator, a vision that, if achieved, could forever change how humanity explores space. First proposed in 1895 by Russian scientist Konstantin Tsiolkovsky, the idea was inspired by the Eiffel Tower. Tsiolkovsky imagined a giant tower reaching from the Earth's surface to a height of 22,000 miles, or around 35,000 kilometers, where it would orbit in sync with the Earth's rotation. Since then, the idea has grown, capturing imaginations and inspiring scientists worldwide. At the heart of the space elevator concept is the tether. This tether would extend from Earth's surface to a point in geostationary orbit, effectively allowing a climber to ascend without a rocket. But the biggest challenge is developing a material strong enough to hold up against gravitational and atmospheric pressures. Quote from Dr. Brad Edwards, NASA scientist, "The material has to be over 100 times stronger than steel. Current advances in carbon nanotubes bring us closer to realizing such a tether, but we're still not quite there yet." Dr. Brad Edwards, one of the leading figures in space elevator research, points out that while we are still working on a material capable of meeting these demands, carbon nanotubes and graphene may hold the key. A functioning space elevator would dramatically reduce the cost of reaching space. According to NASA, today's cost to launch a single kilogram into orbit is around $10,000. But with a space elevator, these costs could drop to just hundreds of dollars per kilogram, opening up space access to everyone. Quote from Dr. Michio Kaku, theoretical physicist, "If we could build a space elevator, it would allow us to carry large amounts of cargo and people into orbit at a fraction of today's costs. This would make ambitious projects like space colonies, moon bases, and Mars missions far more realistic." Dr. Brad Edwards, one of the leading figures in space elevator research, points out that while we are still working on a material capable of meeting these demands, carbon nanotubes and graphene may hold the key. A functioning space elevator would dramatically reduce the cost of reaching space. According to NASA, today's cost to launch a single kilogram into orbit is around $10,000. But with a space elevator, these costs could drop to just hundreds of dollars per kilogram, opening up space access to everyone. Quote from Dr. Michio Kaku, theoretical physicist, "If we could build a space elevator, it would allow us to carry large amounts of cargo and people into orbit at a fraction of today's costs. This would make ambitious projects like space colonies, moon bases, and Mars missions far more realistic." Once built, a space elevator would allow us to move both people and equipment into orbit regularly and with ease. It would also transform satellite deployment, maintenance, and space station resupply. Dr. Michio Kaku believes this technology is crucial to our becoming a multi-planetary species. So, how would it work? Well, a climber, or elevator car, powered by solar energy or laser beaming would move up the tether, carrying payloads to orbit. This journey would take about a week from Earth's surface to the top, but without the risks associated with rocket launches. Quote from Peter Swan, president of the International Space Elevator Consortium, "Imagine cargo and crew moving continuously from Earth to space without fuel constraints. We could reduce emissions, costs, and make space exploration far safer and more efficient." But this concept isn't without challenges. First, there's the need for a stable base, likely an offshore platform near the equator for better stability. The Earth's rotation would then keep the tether taut, like a stretched rubber band. In addition to materials and structural challenges, there are also concerns about space debris, which could collide with the tether. Space debris is a serious threat. Scientists are exploring potential solutions such as protective shields or moving the tether in response to incoming objects. This is a top priority, as one collision could damage or destroy the tether. Quote from Dr. Yuri Artsutanov, pioneer of modern space elevator concepts, "We must consider the impact of micrometeoroids and space debris. With enough research, protective measures could be developed, making the space elevator a safe mode of transport." Looking toward the future, experts predict that a space elevator could be built by the late 21st century. Advances in nanotechnology, materials science, and robotics will be crucial in making this dream a reality. A space elevator would open up unprecedented opportunities for human exploration and provide a sustainable pathway to Mars, the Moon, and beyond. Could the space elevator be humanity's first step toward becoming an interplanetary civilization? One thing is certain. With each technological advance, we're one step closer to making this science fiction dream a science fact. Thanks for watching. Don't forget to like, subscribe, and stay tuned as we explore more groundbreaking space concepts and missions.